afternoon. We are going to be talking about Purge and Track troubleshooting made easy. I've made a few announcements. If you could please put your phones on mute, that would be greatly appreciated. It really helps to cut down on your background noise. If anyone is on a cell phone, usually you push *6. My name is Tammy Reller, and I am one of the application sales specialists, and I see a lot of my customer base out there, so I'm glad you are able to join us this afternoon. We had a lot of great questions sent in, and quite a few of those focused around very similar topics, which Tyler and I will be covering for the next hour. And if you do have something critical, I think you are able to type a question in as we go, and somebody will help and get that information to us. I'm here with Tyler Trent, and he is one of the applications chemists, and he will be hopefully traveling out in the field with me soon and making some calls with all of you. Tyler has been with us for about a year now and specializes primarily on the VOC side of things. So he's been working a lot with the Stratum and the Atomics and the Aquatech 100 over the last year. So once again, welcome, and we will go ahead and get started, and I'm going to turn it over to Tyler. We are actually going to tag team this so that there's a lot of information to be covered throughout this webinar. And we also have Preston Hoppus on the line, who is part of our international tech support and one of our former field service engineers. And he is going to also help us with any type of specialized service questions that someone might have. So once again, please put your phones on mute, and we will go ahead and begin.
Good afternoon, everybody. A couple of topics we're going to be covering today in the Purge and Track troubleshooting made easy. There are no response, carryover and contamination, elution issues, early, middle, and late, water interference, internal standard recovery variability, linearity, reproducibility issues, system leaks. Then also we'll cover some miscellaneous topics at the end that fit in with the PowerPoint presentation. First, a little bit of troubleshooting tips that we're going to be talking about. First, you want to take a moment to review the manual. The manual is there to help you with the assistance of flow diagrams, and there's also a troubleshooting section in most of the manuals that are published out today. When you start looking for problems with your instruments, you're going to examine the facts and use valid reasoning. Valid reasoning, what I mean by that is looking at the data that comes off of your reports, your chromatograms, and get a feel for what's going on. If you have missing peaks, little or no response, or your internal standards are bouncing around. That will help you identify the root cause of your problem, to help you identify if it's coming from your GC mass spec, your Purge and Track system, or your auto sampler. And one thing that we urge you to do is avoid quick fixes, because quick fixes will hurt you in the long run, because it will make you have other problems down the road. And also to avoid the shotgun approach. Shotgun approach is when you basically throw everything on the first try. We suggest you replace one thing at a time, change one variability, and then that'll help you eliminate your problems as you go down in the troubleshooting steps. First, we want to find the root cause. Basically, you have four separate entities you want to separate this into: your detector, your GC, your Purge and Track, and auto sampler. You always want to start with your detector and work backwards, and have your auto sampler as the last one you want to troubleshoot. First, we want to go through and try to eliminate this GC mass spec. It is not necessary to disconnect the Purge and Track, because it is cut into your inlet lines. The first thing you want to do is confirm the normal operation of the mass spec.
Please put your phones on mute if possible. Thank you.
You want to confirm the normal operation of the mass spec. You want to make sure your tune is still up in tune. If your VFU doesn't pass, which most EPA methods require a VSB tune. So if your VSB tune starts to fall out, you might want to retune and check your parameters. Also check your vacuum, make sure your vacuum is holding steady at a constant torque that you were hooked down to -6. Also make sure you maintain your source. This can also help eliminate problems with the mass spec. And then after you eliminate the problem with the mass spec, then you can move on to confirming the normal operation of the GC. For that, you want to do a direct inject to the same center that you use in your Purge and Trap concentrator. And if you see poor chromatography resolution, poor resolution, or reduced response, then you know your problem lies within your GC. Couple things could be your inlet liner and septum could be dirty, or also maybe your column, you need to clip your column and start with a new fresh entrance to it. Then once you confirm the normal operations of your mass spec and GC, you can then proceed on to the Purge and Trap and the auto sampler.
We can do that to make it come on.
So after you eliminate your GC mass spec, you want to then move to your Purge and Trap. You want to confirm the normal operation. The first and most important thing to do is run a leak check, because the leak check will help you identify if there is a leaky valve or a connection that's not leak tight, which could cause some problems down the road. Also, if you have the capabilities of running a diagnostics, such as a benchmark that we have on our Teledyne Tekmar products, that will basically help you identify the problem, where the problem is, if it's a leaky cylinder valve, if your temperatures are not reaching correct temps, your pressures or your flows. This benchmark will help you identify the majority of the problems are solved within here and point you to the correct spot. Another thing you want to make sure is when you're confirming the normal operation of your Purge and Trap is to make sure you have the correct analytical trap in place. Sometimes the numbers are hard to see on the nut that holds it in tight, so you want to make sure you have the correct trap for the project you are working on, and it's not a blunt trap that doesn't retain any compounds. And then to start off, to troubleshoot your Purge and Trap, you want to manually load your samples into the Purge and Trap. This basically eliminates the auto sampler completely, and then you know you're actually getting your sample into the sparge vessel itself.
Now, for some of those that have, say, maybe the newer Aquatech 100 or the Aquatech 70, you would disconnect the peak tubing and put a plug right in there at the sample mount, and take a 5 ml or 25 sample syringe and go ahead and inject your internal standards and surrogates into that as well, and then manually load that into the front of the concentrator. We still have a few people that do not have their phones on mute. If you could please do that, that would be great. We're hearing some noise in the background and it interferes with the webinar.
First topic that we're going to be talking about is no response. This can be broken down into a couple categories here.
Yeah, I've heard it. What can I do about it?
The first category that we're going to be talking about is are the analytes given to the GCMS. First, you want to make sure with this, your trap, you want to check your trap heater. Is your trap reaching the correct set point to desorb the analytes off the trap? Also, with this part, you might want to check your flows here also too, because if you don't have the correct flow setting going through your trap, you may not get all the analytes off your trap with the temperature. So after you've verified that your temperatures are working and your flows are set correctly, then you can move on to the next step by checking your 6-port valve that sits on top of the Purge and Trap. The first and main thing you want to make sure is that you hear the valve actuate. If you hear the valve actuate, you know you have power to the valve, and the valve is actually rotating inside. So that will help you eliminate a couple more problems down the road. One big problem that might happen is the 6-port rotor might be installed incorrectly, because with the transfer line coming out of the stratum or your velocity or your Purge and Trap concentrator, it's a constant loop that is broken off from the Purge and Trap to the GC. This is where your inlet flow circulates through your transfer line. And if it happens to be off by 180 degrees, you can possibly see your front inlet pressure drop. And this is one way to tell if your 6-port rotor is installed correctly into the Purge and Trap system. Then another section of no response is, are you actually sparging the sample? So are the analytes getting to the trap? Do you see bubbles in your sparge tube? This is the first couple questions you should ask if you're starting not getting a response. Then if you're not seeing any bubbles into your sparge tube, you might want to recheck the system, make sure you don't have a leak. Then after you make sure the system is leak tight, the next step you should go to is make sure your flows are set correctly in your method. Typical US EPA methods are 40 mils a minute for 11 minutes. That's the standard flow that most of everybody uses. And make sure that will help. If you don't see the bubbles, then you want to start working your way back to where your gas is coming in. Have you recently changed your tank? Did you, by a chance, bump your regulator and change your regulator pressure gauge? Regulators are typically set anywhere from 65 to 85 psi for the Purge and Trap systems and the GCMSs. After you make sure all of that's working correctly, then you might want to go through and start looking at your mass flow controller, which is in our
Yeah, it's in the newer system. So for those of you that have older systems, say the 2000s, the 3000s, 3100s, and even the current systems, you're going to take a flow meter and you're going to measure the flow out the vent as the system is stepped into purge. And you want to make sure that you have 40 mils a minute coming out that vent. For the older systems, you would normally be setting it on your pressure regulator on the front of the system. On the newer systems, such as the Stratum, they have mass flow controllers, so all your flows are set in the software. You will be able to read the actual, you will get a read back on the flow in the software, but you will also still be able to measure that flow out the vent.
Now we're going to look at a flow diagram that we have just for the purge section. So this is basically tracking your gas flow to the sparge tube that will allow you to get your analytes off to the trap. Basically, you enter through the mass flow. I'm going to be following this with the cursor. You enter through the mass flow controller. You should have the flow coming out that should be 40 mils per minute. Then you come down, and then you enter through the bake valve. Then you go through the bake valve, through the common, to the normally open. Then you go out to the purge valve. Through the purge valve will allow you to take up to the sparge vessel. The sparge vessel, then you'll be purging your sample inside there. Then it'll be going through the full-way heated tea. Then it'll pass through the 6-port rotor valve, through the condensate trap, then through the analytical trap where your compound should be held at. Then the purge gas should be coming back around, and then blow straight out of the vent where Tammy was saying that you can put a flow meter and you should be reading 40 mils per minute. If you're not reading 40 mils per minute, somewhere along that green pathway, you have a leak, or you have a bad valve that's not actuating, which is causing a blockage of your flow. Then after you eliminate your purge and trap auto sample for no response, you're in response to your purge and trap, you want to check the auto sampler. So the first question we're going to ask ourselves is the sample getting transferred over to the sparge vessel? Do you see the sample being pulled? Do you see the sample being placed into the sparge vessel on the purge and trap? There could be a couple of issues related to this. Most of these systems are pressure driven, unless you have the atomics, which is syringe driven. The pressures need to be set correctly for the sample to be pulled. Typically, it's anywhere set between 6 to 8 psi. That's coming from the manufacturing floor, and it shouldn't be changed. Then basically, if you see your sample getting pulled, then you know you have your pressure set correctly. Basically, one thing you want to see is if you think you're not transferring the correct amount of sample when it's getting pulled, you can take a 25 mil syringe and take a 25 mil sparger and place 25 mils of water in and mark the two water lines. Then have your auto sampler pull the same amount and see if your water lines match up. Then you know if you're roughly close to your settings that you need to be, the correct volume. sometimes the valve, if you have a leaky valve that's leaking cross port, or a valve that's just not working correctly, it goes bad. Some of these would be the sample valve or the drain valve inside the auto sampler. If the drain valve is leaking and doesn't shut off, the sample could possibly leak cross port and out of the loop, and you may not get your correct sample recovery. So this is if you're losing sample, this could be a possible check where you might look for where it's going, where it's leaking out of. Basically, right here shows, this diagram right here shows the Aquatech 100 and the pressure and how it's pressure driven to go back and pull the sample. Basically, you have your regulator that is set anywhere from 6 to 8 psi. You go through your pressure sweat valve. Right here, it also sweats. Your internal standards are also pressure driven, so that gets cut off, and those will stay pressurized throughout the whole time, so you have a complete inert atmosphere inside your standard vessels. But as the pressure builds, it goes up through the pressure valve, and then through the sample transfer valve, and it goes through the three-stage needle that allows it to pressurize inside the valve. That pressure will drive the sample up and through the sample valve to fill the sample loop and out through the drain valve. As the sample loop is on a time system where you set to fill how many moles you want. After it gets done, it clicks off the valve and it sets it to be sample transferred. And if you have a leak and your sample is leaking out of your drain valve, it'll be going to drain. Also, if you might have a leak through here, you might be losing your sample back into your sample pathway from where it was being pulled from the needle, if after the valves have been shut off.
Please press *6 on your phones to mute.
The next big topic that we're going to be talking about is carryover / contamination. Carryover is not just for the eluters. It is also for a full target list of your analytes. And contamination can be anything present within your sample that's what you're not looking for. First thing you want to do, what we always want to do, is separate the systems into their 4 entities again. You basically want to run with GCMS only. So set up a run and just press start on front of the GC panel. This will show you that if you have contamination or your carryover is in your GC, because you can look at the chematogram and see, is it a clean chematogram, or what are these peaks I'm seeing? Are these analyte peaks I'm looking for? Are these going to cause my carryover? Are these going to cause my results to be skewed? Then after you eliminate your GC, you can move on to your Purge and Track. So basically you can step it straight to desorb, and just desorb a empty system without no sample in there, and have the flows carried out, flows and temperatures, take off anything that's in there to see what's in there. If you have some analytes left on the track, this should tell you what's on your track. If you have any carryover coming from your system, and that will allow you to go about the correct steps of eliminating a carryover. Another big concern about carryover contamination is your temperatures. If your desorb temperature is not reaching a set point, you may not be able to get everything off the trap. And if you're not getting everything off the trap, that's going to cause carryover, and that carryover is going to be in your next sample. Also, you want to make sure your bake temperatures and bake flows are set correct and are working correct, because the bake allows you to help to clean up the system with, I believe it will heat the system, and then the flow will push out any analytes out the vent. So that will help to clean out your system also. Another thing is, make sure your water rinses are working correctly. One thing about these Purge and Track systems and auto samplers now is that they have the availability to do a hot water rinse. And this hot water rinse will allow you to flush hot water limit at 90 degrees C through the sample pathway to help clean it up. And on the stratum and then the tonics, the hot water rinse is user settable. You can set how many mils of water you want to be pushed through the system and how many rinses you want. Instead of doing one rinse, you can do two. You need to do more than two. If it's a high sample, you can do 3 or 4. Another key feature is when you go on the atomics, since it is a soil and a methanol extraction instrument, that you get really, really high samples. Those really high samples can contaminate your sample pathway and need carryover. One great thing about this is you can use a methanol rinse. Basically, we'll use methanol from a reservoir and rinse the whole system, rinse the sample pathway with the methanol to help eliminate the carryover that you might see.
And when we refer to the sample pathway, we're talking about the syringe that is delivering the sample. It is also going to cleanse the needle, and it's going to clean up the sparge vessel as well in any areas that reaches that sample pathway. For many of you that have older systems like the LSC 2000, I think and some of you that still have it, if not, you'll remember that we tended to have high bake times on those, somewhere in upwards of 10 to 12 minutes. Mainly that's because of the type of tubing. We used nickel tubing back in the day, and you didn't have as much control over the flow. You would only be able to you would have to set your bake flow to what your purge flow was, which is usually 40 mils a minute. One of the nice things about the newer systems on the market is that most of the tubing has the latest and greatest as far as inert types of tubing, whether it's in the sample valve or whether it's in the transfer line. The sample pathway or the sample transfer lines are now peak tubing. And also we have the mass flow controllers. So you can set your purge to still be 40 mils a minute, but now you can ramp up your flows to 200 or sometimes even 300 mils a minute during the bake stage and really push anything that's left over on that adsorbent trap off and out the vent. So that's going to take your times down. So as over the years, as we improve things within the tubing and flows, we are able to now, get those bake times where they used to be in upwards of 10, 12 minutes down to maybe 2, 3 minutes, just depending on, what you set your bake flow at.
We're going to talk a little bit about carryover of the full target list. As we go through this, we want to take our steps and eliminate the GCMS first, then we'll go to the Persian trap, then we'll go to the auto sampler, and we'll talk about it that way. First, eliminate your GCMS by doing your run only. Maybe a couple option that could be a problem is a faulty EPC. But also, once we get to our Persian trap, we'll go to a little bit more in detail. With the Persian trap, maybe you have a solenoid valve leaking cross port. The solenoid valve leaking cross port might have the high sample leak over into a pathway that's not being used until the next run when it's pushing sample through. So if you're running a high sample, then all of a sudden you run in a carryover study afterwards, and you see that could be a possibility because that is the high sample did leak across the port into the sample pathway that's not being used until the next run, which could cause some carryover of your full analyte list. Also, you could have a faulty trap heater. What a faulty trap heater is, your trap's not heating up as high as we need to be. The temperatures aren't reaching their set point. This can be seen on the side, just checking on the diagnostic screen, on the set point screen, if you see if your zones are reaching their correct set point. And if it's a faulty trap heater that's not reaching the correct set point, it might be leaving a lot of analytes on the absorbent trap, on your analytical trap before it's deabsorbed, and then maybe those are skewing results for carryover on the next sample and making your samples be elevated. Another possibility for a full target list carryover would be the sample is not draining correctly. The sample, if it's not draining entirely and still be left a little bit in the sparge tube, then the next sample that comes through will be mixed with it, and then it will be sparsed, and then you're going to have that high sample or extra analytes that are going to be present in your sample, in your results. Or also dirty glassware. If the glassware is dirty, say if you're trying to make a standard on the bench and someone didn't rinse it out, it had a high standard in it before and it wasn't rinsed out properly, this is where you might get your some carryover from that, some dirty glassware. Also, your sparge tube not being rinsed correctly or cleaned out correctly with the water rinse, with the hot water rinse, and things like that. Then if you move over to your auto sampler, one key thing you want to try to do, if it is available, is to compare your soils versus your waters. Because typically these two pathways are very independent of each other. They only share the sample pathway of how the sample gets there sometimes. And if one has it and the other one doesn't, then you can eliminate to where your problem is in that sample pathway. Another thing for your auto sampler is if it's not cleaned up correctly, if your system is not being rinsed. If your hot water rinse is not hot enough, it might leave some compounds behind. It may not clean the needle up correctly. So you want to make sure your rinsing system is properly working. If you have a rinsing system, if you have a current system or a system that went out within the last couple of years, just be aware that the older systems, some of those do not have hot water rinsing on there. So if you do have that, that is one possibility for the auto sampler. Then another possibility for the auto sampler to have a full list carryover would be if your internal standard valve is leaking across port. So say you're pushing your sample through the internal standard manifold, and if it's leaking, it's going to allow some of that sample to be pushed back into the reservoir where your internal standard is being stored at. And if then the next run that comes through, that sample that was pushed back into the internal standard vessel might be shot back in to cause carryover on that one. Then you go through and make sure your internal standard valve's working correctly and it's not leaking across the port. Then carryover for late eluters, which is typically what we see from day-to-day operations sometimes, is your heavy compounds, your naphthalenes, your hexachlorobutadienes, compounds that are at the very end of your spectrum. Some of these, first we want to go through and eliminate the GCMS again, or your GC and whatever detector you're using. Possibility there is your inlet might be cold. With the inlet being cold, it could be a spot where the compounds just gather and just sit there, act like a cold spot. But after you eliminate your GC and GCMS, you move to your Purge and trap once again. Over here is when we start seeing late eluters being carryover, is we're looking at, we may not have enough bake. We may not have enough bake time. Our temperatures and flow might be correct, but we're not given enough time to bake. Instead of 2 minutes, we might need a 4-minute bake. So that can be optimized with a carryover study. Then also you can have a cold spot in your line outside the trap as it's getting transferred from your trap to your GC. There might be a cold spot, which could possibly cause your carryover of the late eluters, because those don't really want to move because they're heavy. Once they reach a cold zone, they just want to stay stagnant. A faulty condensate heater or a faulty trap, once again, if your trap is not heating correctly or you are not baking well enough, the heavier compounds can sit on there and come out on the next run. So these are a couple things you want to go through and check, make sure your temperatures are reaching, you don't have no cold spots, and that your transfer line is correctly working. Then when we move, after you eliminate your Purge and trap, you can move over to the auto sampler. The auto sampler, again, if it's available, check waters and soils. Then once again, you need to check your hot water rinse if your rinse is failing. For the other systems, you might have to rinse it out manually by hand by forcing a lot of blanks through there. Not enough bake rinses. Maybe one bake rinse is not enough. Maybe you need to go up to 2 or 3 bake rinses of the hot water to push it through, to clean up the system completely. Or maybe your sample needle is not cleaning up. Maybe you ran a high sample and you need a little bit longer sample needle time, so you might need to rinse your needle a couple more times than just once. Then basically, then also saying if your bake rinse is not transferring to your purging trap, maybe you have a valve that's being clogged that's blocking the path of the bake rinse. Maybe there's a leak where the water might not be able to be pushed because the system is pressure driven, may not be able to be pushing the bake rinse through the purging trap. Then right here basically is just a diagram of the carryover, how we get the bake rinse fill from showing the hot water going through the loop, and then that rinses the needle. This is how we rinse the needle right here. And then after, once it's being transferred over to the purging trap, the flow, you can see the flow is reversed. It comes through the drain valve, then the hot water is then pushed out through the sample valve to the purging trap concentrator.
Now, the newest systems, you are able to rinse with hot water, so you're able to go through the sample pathway with the 90 degrees water. The atomic system, as Tyler mentioned earlier, you're able to do waters, soils, and methanol extractions. Even if you don't do the methanol extractions, you still have the ability to use methanol to rinse the system. I had a situation in the lab a few months ago where I had a Teledyne contaminant in there, and I couldn't figure out, I troubleshooted, I couldn't figure out where it was coming from. So I was able to just go into the software and program in about 7 to 10 mils of methanol that I ran through there a couple of times. And so it rinses through it's going to rinse through the syringe and through the sample transfer line to the sparge vessel, and the needle. So it's going to clean out all of those areas. And you can vary the volume. So if you're running 25 ml sample sizes, you can run larger volumes of methanol. You can vary them by method. Say you're running a really high level sample, and you don't want to waste methanol, so you don't want to use it after every sample, but you happen to know that sample number 10 is really, really a nasty sample. Then go ahead and program in a different method for sample number 11 that you want to add a methanol cleanup in there afterwards, that you want to do a methanol rinse once that sample goes into bake. And then you can also follow that with a hot water rinse as well. And it's just some additional features that enable you to clean up the sample pathway. This is just some example of a study that we ran looking at the heavy compounds. This is used on the atomics. And as you can see, we're looking at percent carryover of the last 4 compounds. Please push mute on your phone or *6. I can.
Program the methanol program and
excuse me, we can hear people talking. If you could please press mute or *6. So the blue line, as you can see in the data, is where we're using just a 90 degree with a 1 water rinse. And the biggest thing to take away from this is when you're looking at the orange line on each of these 4 compounds, how much we've been able to reduce the carryover just by putting in a 3 ml methanol sparge or methanol rinse after we ran the sample. So we were able to very much decrease the amount of carryover just from going from a hot water rinse to adding in a methanol rinse, and I'm sure we also followed that with a hot water rinse as well.
The next major topic that we're going to be talking about is elution issues. With this, we're going to be covering early, mid, and late. First, we're going to go through our steps again. Eliminate the max spec, eliminate your detector, eliminate your GC, then we'll move to the purging trap. As you can see, you can tune. If you're missing some piece, it might be a bad EPC, or your column might be degraded. Once you get to the purging trap, a good way to see if you're getting your compounds, the elution issues, if you're missing peaks or so on, is do a top of the trap injection, which is explained in the manuals. That's why we say take time to review the manuals in the beginning, because this will explain the technique of how to do it. With the early groups, which are your gases and your lighter compounds, to eliminate your GC, you might have a split flow leak or a bad column. Once you get to the Purge and trap side, you want to make sure your system is leak tight, because a small leak after your trap or a small leak within your trap connections, you might be losing your gas compounds as it's being desorbed out to the GC. Possibly your water front might be too large. With the water front, that ties into desorb time and your dry purge. The longer you dry purge, the more water you're pushing through the system, trying to get it out. That might end up on the column. Another thing is with the too long of a dry purge, your light compounds, you might blow those off the trap to the vent and you may not recover them at all. Or you might see tailing or fronting, depends on how much diesel or dry purge flow you're pushing on through there.
So also, for many of you that know that have been to my seminars before, I always tell the story of when I was losing the front end of my compounds. And so if you're purging onto a hot trap, that will happen just as well. Your compounds, your beginning gases and everything like that, all they're doing is they're hitting that hot trap and they're going straight out the vent.
Then the next group that we're going to be talking about is the middle elution group. This is very rare. We really don't see it. So GC, you might have your column phase might be bad within your GC, so you might want to check your column. Then when you move to the purge and trap, you want to check your desorb properties, like your desorb preheat problems. Maybe you have too much water building up on your condensate trap. Make sure that trap is as cold as it can be. Then as it goes through the bake process, it heats up to the correct temperature to bake off the water, to flush out the water out of the system. Or maybe your mass flow controller is leaking and you're not getting the correct flow to be pushed through the trap, so that you may not be getting all the compounds off. Your flow might be too weak to push everything off the trap into the GC. The next one is the late elution groups. This is basically you want to go through and eliminate your GCMS again. That's the first step of it in any process you go through. Maybe you need to do some source maintenance. Maybe you need to check your carrier flow, your temperature program, your method, and you need to make sure those are all working correctly. When we go to the purge and trap side, most of these late elution compounds that will give you problems are your purge. They have poor purge efficiency. They might be getting restricted in the sample tubing. If you have a bend or a kink in the tubing, that might be restricting the sample flow. Also, dirty glassware. The heavier compounds, unless they get stuck to something, they really don't want to move. They want to stay there if it's at ambient temperature. But then maybe you're not heating your sample properly. So if you're using a sample heater during your purge, if it's not heating properly, you might be getting bad recovery for some of your heavier compounds, because they like a little bit of heat to get them motivated and get them out of that water. So make sure your sample heater is working properly, or maybe your vent valve is plugged. Or possibly you have a bad trap. The bad trap might be holding onto the compounds and not releasing them how it should be, because they're heavy. They don't want to move off the trap. You need that heat to get them going to the GC. The next major topic that we're going to be talking about is water interference. As I've been saying before, we want to start with our detector, so we're going to make sure our mass spec is working correctly. Do we have any vacuum issues? Did we do an air and water check on it? What's our percent water within our system, in our mass spec? Then if you have some water issues with the GC, you might want to check your split flow is too low. You're throwing a lot of water, a lot of sample onto that. So that might cause your front end to be overloaded with water, maybe a bad column. After you make sure your GC and GCMS is all fine and dandy, then you move on to your purge and trap system. Then you work back to the condensate trap, because this is what controls your water management system. Is your condensate trap settings correct? Is your condensate trap failing? Then you want to make sure your dry purge is your dry purge not optimized? You want to optimize your dry purge, because the longer the dry purge, the more water you might be throwing onto the trap. More water might be throwing onto the GC. Sample temperature concerns, or maybe they're too hot. If your sample's too hot, you're just going to blow stuff back through the trap. If your trap and your condensate trap's hot, it's just going to keep going and it's going to blow it straight out the vent. You won't recover anything but the water. Then also a key factor is your desorb time. If you, depends on what method you're running, typically it's 4 minutes desorb time, but as you can see on the next couple slides, the 4 minute desorb time has a bigger waterfront than the 2 minute desorb time. And this right here, this chromatogram shows you the green is a 4 minute desorb of a blank, and then the white is a 2 minute desorb of a blank. Then we also look at this chromatogram where it shows that the waterfront at a 2 minute desorb at 1 ppb compared to a 4 minute desorb at 1 ppb. The waterfront basically ends for the 2 minutes at 3.3 minutes. That's where the waterfront ends and the baseline returns to normal. Then for the 4 minute desorb, you can see the 4 minute desorb at 1 ppb goes all the way out to 5.3 minutes. So there's a big difference in where the waterfront ends. And also you can see the elevation in the 4 minutes, which could cause some effect on your recoveries of your sample because your baseline is high. And make sure your waterfront is consistent. If your waterfront is not consistent throughout, this could cause some problems within your system.
This data has just been done recently by Tyler on the stratum. We had several requests coming in, primarily from the East Coast, looking for, say, 2 minute desorb versus 4 minute desorb and what the differences are between the two. So some of this data has just been recently run within the last 3 weeks, and this was done on a stratum. So I just wanted to let you know that, one of the newer systems.
Now we're going to move on to internal standard recoveries. Basically, we want to eliminate our GC. So if your GC response as target compounds increases as your compound concentrations increase, you might have a dirty inlet liner or source. Validate it by making 3 standards, injecting 1 microliter of those standards onto the GC. And if you still see the trend that's happening, you might need to replace your inlet liner or perform some maintenance cleaning of your GC system or your mass spec system. Then we move on to the Purge trap. Typically, what we've seen in the past is if you have internal standard recovery problem with your Purge trap, it's typically isolated to an active site, either in your sample tubing, condensate trap, or your analytical trap. Then after you eliminate your Purge trap, you move to your auto sampler. You always want to hand spec your vial first, no matter what you do. Hand spec your vial to make sure you're getting your recoveries the way you want them. Then you check your automated delivery system. Is there any tubing restrictions? Is your internal standard manifold valve functioning correctly? Then you want to check your pressure problems. You're not getting enough pressure to force the sample in your internal standard valve and vessel through the manifold valve. That's where we want to make sure our systems are staying anywhere between 6 to 8 psi. This basically right here shows a diagram of how the internal standard is pressurized and where it's going to be delivered into the sample pathway on the new Tech 100. Then we're going to go to the next topic we're going to be covering is linearity and reproducibility. I'm not going to hit on these topics as very in detail, but for your GCMS, you want to make sure your source is maintained. You have no vacuum problems, possible bad EPC failure, bad column could cause bad reproducibility. Your method is not optimized. Your oven temperature program is not set correctly for how according to your method, or maybe your multiplier is struggling and it's going bad by adding a lot of EM voltage. Then we move, after you eliminate your GCMS, you move over to your Purge trap. You want to check your linearity and reproducibility. First, you want to check your method. Make sure your method is optimized. Is your method optimized? If your method is not optimized, you want to go through and take the steps to make it optimized and working to the specs of the specs to the EPA method that you're using or the ASTM method that you're using. Also, maybe your trap is failing. Do you see your brominated compounds coming in with low recovery? Do you see your heavier compounds starting not to recover as good as they once were? That's signs of a failing trap. Also, maybe your drain valve is leaking. Maybe you're not getting, when you're purging your sample in the stratum, if your drain valve is leaking, that pressure is going to force that similar liquid up the drain tube, and it's going to force it out to the drain, out the waste, and you'll be losing sample as you're purging based upon the pressure. is there excess water in your system? Is your desorbed temperature, are you desorbing too longer than you should? These can be optimized within your method and within some research that you guys can do. Also, your temperature settings, make sure your temperature settings are reaching this. If they're not reaching the set point, this could cause linearity and reproducibility because it will not allow some compounds to be desorbed off the trap, or maybe you're hitting a cold spot somewhere within your line if these temperatures are not reached according to the specs that are set forth in your parameters. Maybe too much carryover, maybe your system is not being cleaned up correctly, or sample prep errors, dirty standard syringe, dirty glassware, too much headspace in the vial, or just variability between analyst to analyst. Now then, we'll move to a linearity reproducibility on the auto sampler. Maybe it's not pulling the correct amount of sample. Maybe one sample pulls 5 mils, one sample pulls 10 mils. But then this is where you want to start checking your pressures. Is your pressure in your auto sampler fluctuating? Do you need to make sure that's set at a steady amount? Your sample not transferring correctly. Are you losing some between your sample pull to your purging trap? That'd be troubleshooting some of the valves, the sample valve or the drain valve. Or just improper rinsing, and improper rinsing basically means you're not getting out all the analytes from the run before, which is associated with your carrier, which could cause some linearity and reproducibility problems based upon higher results or maybe lower results. You never know. Also, you want to determine if your internal standard, if your IS is varying. If your IS is varying in concentration in the area counts, if your IS is varying in the area counts, this might make your diagram look unstable because basically all your calculations are based upon your internal standard, the area under your peak. So if it's varying, you want to make sure you want to troubleshoot that and look. This could be a source of reproducibility. Maybe it's just with the internal standard that's causing the linearity issues and reproducibility issues. Then the key thing we hit on before you do anything with the purging trap is you want to make sure your system is leak tight. Basically, with the velocity and the stratum, you can leak check the systems. The software leak checks the systems for you, correct? Very fast and automated. With this, the left picture is under the diagnostics tab of leak check, and this is where you can set your leak check pressurization time to, how long you want to be pressurized, the leak flow. Typically, if you want a 5 mil splurger and you run a leak check, you want 100 mils a minute for the leak check flow. If you want a 25, you might run a 200 mils a minute for the leak check flow. And you never want to really change your leak check delta, because the larger your leak check delta is, means the more the leak you have. You want to keep it below, you want to keep it at 1, so which is good. Anything below 0.5 delta, the leak check is great for the system. It means it's very leak tight. Then on the right is just a screen capture showing that the system is pressurizing up to 25 psi, and that has to reach the set point before 2 minutes is up.
One of the nice features of the mass flow controllers is that even if you have a small leak, it enables your purge volume to stay the same. So if you have a small leak in the system, the mass flow controller is going to compensate for that and increase the pressure so that you maintain a flow of 40 mils a minute at all times going through that sample. And it also works in the opposite effect, that if you for some reason have some type of plug in the system that might be causing a high back pressure, it will also have the same effect, so that it will compensate in order to make sure that that flow stays at 40 mils a minute. Now, once the mass flow controller hits, I think it's 60 or 65 psi, it will shut the system down and give you an error, and then you will be able to monitor that in well, you will get an error on the screen, but you're also able to monitor the purge pressure and the bake pressure in the history log, which is also very important for troubleshooting. I know when you call into the tech support line, the first things they're going to ask you to do are run a leak check, run a benchmark, and they're going to ask for looking at your history log. And that enables us to, for those that have the TechLink software, a week and that you have a mass flow controller, it will give a readback of what the pressures are during purge and the pressures are during bake. And what we're looking for is to make sure that those pressures stay consistent from run to run. If you have a purge pressure of, say, around 7 psi, 8 psi, and all of a sudden that pressure is beginning to increase, that could indicate that there's something going on there. And it's the same thing with the bake pressure. So all of these things are now recorded in a history log that enable us to make troubleshooting a lot more easy and user-friendly.
Basically, right here is a leak check diagram of the stratum and the Aquatech 100. It shows you everything that has to be pressurized. And once the system reaches that 25 psi, the mass flow will cut off, and the system will shut down, and it will try to hold at 25 psi, and we'll measure the difference. This is where we get our leak check at. Then with the atomics, there's a really unique feature with the atomics. The atomics is the auto sampler and purge and track concentrator combined, and it's a little bit more of a complex leak check because there's a little bit more going on inside there. And if you have a leak that fails overall, it will break it down to 3 subsystems. The atomics will break down into subsystem A. The subsystem A will basically measure the leak check, the mass flow controller, the bake valve, the purge valve, the pencil filter, the syringe valve, and the pressurized valve. This will, and it says if it fails leak check in there, then you know it's somewhere within subsystem A, and you can troubleshoot subsystem A itself. Then you can go back and leak check it itself. But after it troubleshoots leak system subsystem A, if it passes subsystem A, it'll move on to subsystem B. Subsystem B is basically will include all the components of subsystem A, plus the syringe, 7-port, the transfer valve, the sample needle, and the soil valve. Then if something fails within this, then you know it's non-subsystem A, so you know it's within subsystem B. Then after subsystem B, say if that passes, you move on to subsystem C. Subsystem C is basically a combination of A and B both combined. Also includes the sample mount, the spark vessel, the drain valve, and the 6-port valve on top of the instrument. And if all these passes, but your overall leak check does not, basically all the signs will point to the condensate trap and the analytical trap because they are not included in subsystem A, B, or C. So this is a unique way to break down the atomics and its complex internal workings to troubleshoot the valves and the syringes.
And this kind of goes along with the whole theory of not taking a shotgun approach, and if all it is a way for us to make it a little bit easier to do a step-by-step fashion in order to eliminate one variable at a time. So it will take you through each of these systems because you are looking at a system that encompasses the purge and trap in it. So when you're talking about the atomics, we've now gone from 4 pieces of, from 4 systems to down to 3. The entire time Tyler's talked about the mass spec, the GC, the concentrator, and the auto sampler. When we are talking about the atomics, you're talking about a concentrator and an auto sampler all in one. And so you also have something now that can do waters and soils and methanol extractions. So this entire leak check and benchmark is a way of going through is a more methodical approach to helping you find the leak than trying to figure out, where all these are in inner working. So it's made it a lot easier for troubleshooting, to have everything all in one system. And so taking this methodical approach will help you get through that.
Then another key feature about some of the newer instruments with the velocity, the stratum, and the atomics is that we have a benchmark, as I hit on earlier. The benchmark, first you want to make sure your system is leak tight. Then if you run a benchmark, this basically checks all your internal workings. Is your solenoid valve functioning? Are your heaters working correctly? Is your flows at the correct mils a minute? Is your 6-port valve rotating? This right here will help you isolate a variety of different problems. So if you have a leaky valve across port, it'll tell you that valve failed across port leak. So it'll help you pinpoint where the problem or the issue is occurring. So this is another great tool to help troubleshooting become a little bit more automated, a little bit more easier.
And we realize that a lot of our customers, especially a lot on the lines today, still have the older systems. There's a lot of 2000s, 2016s out there still working, and you take the similar approach, and you need to split the system. Once you've isolated the leak down to the purge and trap, if with the older systems, we go about it the same way. We take where we're going, and we're taking a bubble meter, and we're going through and just checking at each of your connections to make sure that everything is leak tight. I also encourage you to use those manuals. Sometimes the flow paths can be intimidating, but if you take just a couple of minutes to really follow the colored lines on the flow path, it will, when you first look at that, it could be a little overwhelming, but if you actually trace where the flow is going, it will help you to pinpoint in a much quicker fashion where that leak may potentially be.
Then we'll wrap it up with a couple of miscellaneous issues. So you're draining a sample. Maybe if you look on top of the stratum or your velocity, there's a flag. There's like a little rotation valve on top. So maybe if that valve is rotated 180 degrees offset where it should be, it may not allow your sample to drain because you're closing off the drain valve. Or if it's open to where you place your little syringe, your system will not pressurize because all your purge flow is going to basically straight up and out of the Hamilton valve. Another thing is communication issues with the GCMS. If you sit there and see your GC is ready and your purge and trap is desorb ready, but it's not desorbing, you might have it on the wrong communication loop. Is your system a standard 63 or is your system a user 31? These can be switched within the diagnostics tab in the software. As Tammy hit earlier, the history log will allow you to check your purge and bake pressures. So you say if sample 16, all of a sudden you have no recovery, you can go and check your purge pressure. Did you get purged? Did your system bake out? Or what errors happened if an error did happen, and what mode it did happen in. So this is one efficient way to help you troubleshoot your problem is in the history log also.
All right, that ends this part of the webinar. To see if you have any questions, I'm going to go look over here and see.
I don't like this. Give us five, We're just looking to see if we have any questions. So if you have any questions, go ahead and please. I know we did get a lot of questions in initially, and most of them were talked about carryover and water interference, and I just want to review a few of those. That if you're looking at carryover, look at your bake times, your bake temperatures, your flows, if whether or not your trap might be going bad. We had quite a few questions on how do you know if your trap is going bad, or how often should you change your trap. And that really depends on the number of samples that you run. We do recommend that you change it once a quarter, but if you're running hundreds of samples or running 24/7, most of those laboratories have an idea of when their traps need to be changed. If you start to see issues with your brominated compounds or some of your heavy compounds, it is potential that your trap needs to be changed. Sometimes you will have varying traps within, even within different lot numbers. Some of them may retain a little bit more water than another trap, even though it may be the same BOCARB trap or the same number 9 trap or what have you. But each one of those, even though they're all packed the same, one may hold water a little bit more than the other. So you may need to bake that trap out just a little bit longer. If you are having some water interference, take a look again at your split flows. It would all be really nice if one GC was exactly the same as another, but we all know that side by side on a bench you can have exactly the same make and model of a GC and your parameters will be different. So make sure you take a look at your split flows and whether or not your dry purge is optimized. And and even some cases your scan ranges. And the EPA method, you are able to scan from 47 to 260, and if you're able to take advantage of that, that would be, I highly recommend. We did have a few questions on, and then we also addressed the internal standard precision as well. So we went through all of the questions that were sent in, and we're able to consolidate most of them into those categories: carryover, water interference, internal standard precision, and trap maintenance. So if you have any more questions, we're going to take a look here and see. Okay, this is a good question. Do you have to use a blank trap when doing a methanol rinse? And yes, you do. So if you are doing, say you have a contamination, and this is usually done in some of the older model systems and even any of the newer systems. So say you have a foamy sample and it foams over and maybe mic it in and contaminate your sample pathway, and you want to do a methanol rinse through the system, you will need to put in a blank trap. Otherwise, you will continue to see that methanol forever and ever. I know. Hey, Preston, are you out there?
Yes.
Do you have anything else to add that maybe we, in your experience, that maybe we, haven't touched on or kind of skimmed over?
I guess one of the things that you all did mention, but I just wanted to reiterate, is as far as when troubleshooting, pay close attention to the traps, because a lot of these things are going to be, you can spend a lot of time and money replacing hardware and systems, and the problem turns out to be a trap. And I know that both Tammy and Tyler had mentioned, changing a trap is not necessarily going to fix the problem, especially if you have ordered, say, 3 or 4 or 5, 10 traps, and you've got them sitting in a drawer. You put a new one in, and the same problem reoccurs. It might just be that you've got a bad lot of traps. So I highly recommend making sure that the different, if you're going to keep with the same part number of trap, try a different lot number. Or if you have a different type of trap, maybe an I trap or a number 10 trap instead of the K or a number 9. Even though you might not necessarily want to use that different part number on a regular basis, just put it in to see if maybe your problem goes away, to see if you might have a bad lot number of traps.
Very good. Do we have any other questions? Well, I thank you all for taking the time today to sit with us, and I hope you enjoyed and were able to extract some information out of this webinar. We'd also like to get some feedback. We had an overwhelming response to this, so we'll be holding this webinar again at 4 o'clock this afternoon. And we are talking about putting more troubleshooting into the seminar series that we take on the road with us, but also to be able to do more troubleshooting. And I know a lot of you would probably like to have it more targeted towards certain instrumentation. So any feedback, just like you always do with the seminars that we give, we would appreciate any feedback that you have. And thank you again for joining us today.
Are these typically available after the fact?
Yes, they are. They will be. We are actually audio taping this, and they are should be online up on our website, which is www.teledynetekmar.com, and you will be able to access that probably within the next week. And also be sure to follow us on Twitter and Facebook and LinkedIn. You can find those links on our website as well. I gotta get up.